Okay, Shabab, now we will do csf4203 week 4, chapter 8, which is TCP IP suite of protocols. Why do we need a protocol? Because we need a protocol to communicate between different computers or different networks or different entities. They need to agree on the standards, how they will communicate, on the rules. Okay? Computer communication is the exchange of information between computers for the purpose of cooperative action, yani for communication. But it's better you open it from your computer also. Thank you. Yeah, week 4. All right. I don't know why ليش بيطلع السكرين شوت هيك احسه مو واضح صح؟ Yeah, I don't know why it's coming like this. Okay. And for computer network, it's 2 or more computers interconnected via a communication network. What is entity? Entity is anything capable of sending or receiving information. Examples are user application programs, file transfer packages, database management system, electronic mail facilities, and terminals. These are called entities. What is a system? A system is a physical, distinct object that contains one or more entity. We call it a system. اللي بيكون فيه more than one entity. Okay. Examples of system are شو مكتوب عندكم you can read it there on your computer, on your PowerPoint. Computer, terminals. Computers are system. Terminals are systems, okay, because they have more than one entity. Okay. Protocol, as I just mentioned before, it's a set of rules that governing the exchange of data between two entities. What are the key elements of protocol? ايش هي الأجزاء الرئيسية في البروتوكول? Syntax includes such things as data format, signal level. By the way, this is very important. Comes in the questions here. Semantics include control information for coordination and error handling. And then we have timing, includes speed, matching, and sequencing. So these are 3 key elements of any protocol. You cannot have a protocol, proper protocol, without these elements. Why we need standard protocol architecture? Because everybody wants it. Vendors like it because they make their products more marketable. Customers like it because they enable products from different vendors to interoperate. Okay? So you can get a device or a system from a different vendor, but still it will work on your machine. Okay? 2 protocols architectures have served as the basis for the development of interoperable protocol standards, which are TCP IP and OSI. I'll give you an example, Shabab. Before, not too long ago, when you buy, like, let's say, telecommunication system for your company from Siemens. Siemens was very famous for switchboard, even the telephone sets on the table. And you want to replace sometime or you want to expand, you have to buy from Siemens. You cannot buy from somewhere else, just for example. But nowadays, you can buy, as long as it's the TCP IP, you can use it. Okay. A widely used proprietary scheme is شو عكسها اللي هو proprietary. Proprietary will only work on the system. IBM, they have their proprietary SNA network architecture. SNA is only for IBM. TCP IP OSI for any system. TCP has 5 layers. Some books describe it as 4 layers, but for the sake of our book, our exam, 5 layers. Okay. These are the layers. Please look at them. Application, transport, network, data link, and physical. And each layer interacts with its immediate adjacent layer. Okay. TCP is the most commonly used protocol at the transport layer. Okay. The Internet Protocol IP is the most common protocol at which layer? Internet layer, layer number 3. Network access layer provides the attached network with the information needed to reach a router that connects the network to the next network on the route to the destination. Last but not least, the physical layer is concerned with specifying the characteristics of the transmission medium, the nature of the signal, and the data rate and related matters. Lower physical. PDU in the TCP IP architecture. Now we talked about PDU, you know. The data that is transferred in the layers, when it's moving from layer to layer, we call it PDU. Okay? Protocol data unit. Okay? And the sending process generates a block of data and pass it to the TCP. The TCP control information add header, and we call it TCP segment. يعني اسمها بصير segment. أول PDU بس, now it is a segment PDU. When it goes from the transport layer to the internet layer, the internet layer will add a header to it, and now the name of the PDU is called, look at the TCP segment. لا packet or IP datagram. Okay, and then the network access layer adds its own header and trailer, and it is called, in the data link layer, it's called what? Frame. Please don't forget these names. So we start with data, segment, packet or datagram, and frame, and then at the physical layer it's called bits. Okay, here it is again one more time. See, segment, datagram or packet, frame, and at the physical it is bits. The only layer that adds header and trailer, by the way, is the data link layer. Okay, the other layers, they add only header. Now we have 2 important protocols in transport layer. I think you have studied this in your CIN 2103 course, TCP and UDP. Which one is reliable? Very good. Which one is has 3-way handshake? Very good. Which one is used for applications that needs reliability? TCP. Which one is best effort, fast? UDP. Very good. TCP provides a logical association or connection between 2 entities to regulate flow check errors. Okay. UDP does not maintain a connection and does not guarantee delivery. Okay, but it is fast. And UDP is needed, TCP is needed. IP telephony, VoIP uses TCP or UDP? Who can tell me? UDP, because you need speed. So when you talk, you want the other person to hear you as while you are talking, not to hear one word before the other. Or so okay. So this is the summary. TCP is used for applications that when the transmission time is less critical. UDP is used for that applications that need fast, efficient transmission, such as games. TCP, example for TCP is emails. Emails needs TCP. This is the TCP and UDP headers. By the way, TCP has more overhead, يعني أكبر, الفريم أكبر. الهيدر تاع TCP أكبر. Look, TCP header, how big it is. Source port, destination port, sequence number, acknowledgement, all this. But if you look at the UDP, just source port, destination, checksum, segment length, على طول. Like when you are watching YouTube, you know, YouTube sometimes, if the connection is not that good, you see some, but it will not reload, صح? It will continue. So here we have the protocols in the TCP IP protocol. As you can see here, please, you need to know these names. Okay. The protocols that rely on IP are these protocols. These are routing protocols, by the way. OSPF, IGMP, ICM, and ICMP is also another protocol. Now, protocols that rely on TCP are SMTP, SSH, and FTP, BGP. The protocols that rely on UDP, you are given one example, which is SNMP, Simple Network Management Protocol. Okay. SMTP is for email, and it is relying on TCP. Even MIME, M-I-M-E, okay, which is multi-purpose internet mail extension. So now we will explain some of these applications. SMTP, Simple Mail Transfer Protocol, supports basic electronic mail facility by providing mechanism for transferring messages among separate hosts. It has many features such as mailing list, return receipts, and forwarding. And you receive a message, you can forward it. We have FTP. We all know about FTP, File Transfer Protocol. You can send files from one system to another. Okay. And you can have text and binary files can be sent. Okay. SSH is Secure Shell, provides a secure remote login capability, which enables a user at a terminal or personal computer to log on to a remote computer and function as if directly connected to the computer. This is the secure one. What is the unsecure method? Tell me. HTTP, Hypertext Transfer Protocol, connects client system to web servers on the internet. It establishes a connection with the server and sends HTML pages back to the user browser. And you request a page, it will go to the server will send you the page, you will read it on the browser. Okay. This page is HTML format. SNMP, which relies on UDP, it's Simple Network Management Protocol. It's a widely used network monitoring and control protocol. And remember, this is UDP. Okay, don't forget. This one is UDP. Okay. Routers, they are used to interconnect independent networks. The essential functions of the router is provides a link between networks, provides for the routing and delivery of data between end systems attached to different networks, provide these functions without requiring modification of the networking architecture of any of the attached networks. And a router will connect different networks, will connect your network with the, it will connect your network with the, what you call it, the internet. It will act as a firewall. Just hold on, please. Hello? Okay, that's fine then. Okay, this is just to confirm the login to the application. What are, here they talk about some characteristics of routers or router issues they call them. Addressing schemes. Network may use different schemes for assigning addresses to devices, different subnets even. Maximum packet size. Packets from one network may have to be broken into smaller pieces. We call this fragmentation. Interfaces. The hardware and software interfaces to various networks differ between each other. Reliability. Operation should not depend on an assumption of network reliability. Of course, IP. Is IP reliable? IP, that's the protocol of internet. Internet by itself is not reliable because IP protocol is best effort. We add other services to make it reliable. We add other applications to make it reliable when we need it. But by itself, IP is only best effort. Okay? Like the internet, is it secure by itself? If you want to make secure, then you need to add more like VPN when you want to access your bank account or, okay? Operation of the TCP IP. Please read this and then I will explain and ask you some questions. Operation of the TCP IP. This is at the sender side. Please read the steps. Okay. So the first step, the application protocol prepares a block of data for transmission. For example, an email message. It depends on your application, FTP, Telnet, SSH. And then using a common syntax, if necessary, the data are converted to a form expected by the destination. Okay. Then we segment the data. Where is it segmented? In which layer? Segments. TCP. TCP, transport layer. Okay. TCP. Then it is duplicated. A copy is made of each TCP segment in case of loss and damage or damage. Then fragmenting the segments, the IP or the internet layer will fragment it if it's too big. All right. Then it will go to the data link layer and it will be framed. Framing, yani converted into frames. Okay. Framing, number 6. Where did it go? Where is step number 7? Oh yeah, I was looking for this. Then it goes to the physical layer, and then it will be transmitted as bits. Okay? Then it will arrive at the destination. So the physical layer will convert it back. Then it will go to the frame relay. From frame relay, it will go back to the internet layer. The internet layer will read the IP address, source, and destination. Then it will send it to the transport layer. The transport layer will read the port number to which process this is related, and then it will send it up to the application layer. Okay? Here we have at the application, it is delivering the data, okay, and reassembling user data. If TCP has broken the user data into multiple segments, these are reassembled and the block is passed up to the application layer. Yani TCP in the sender. If the segments were, if it was segmented, when it arrives at the TCP of the receiver, it will be assembled again, okay? And then given to the application. Okay, Shabab, any question? Yani the point here is from the sender to the receiver, from the sender it will go from application to transport to internet to access layer to physical. Then when it arrives to the receiver, it will go the opposite. Physical, data link, transport, internet, and physical, data link, internet, transport, application. Very good. VPN, now we talk about VPN. VPN is used to secure the internet connection because internet by itself is not secure. It consists of a set of computers that interconnect by means of relatively unsecure network. Then we make use of VPN, encryption, and special control protocols to provide security. It uses IP security protocols, IPsec. It provides this capability to secure communications across a LAN or private and public WANs and across the internet. Have you studied this in cryptography? Did you cover this in crypto? No? Okay. Examples of VPN use, of course, everyone is using it now. Secure branch office connectivity, secure remote access over the internet, let's say to your bank account, enabling electronic commerce security, e-commerce. It can encrypt or authenticate all traffic at the IP level. Wow. The encryption is done at the IP level. Thus, all distributed applications, including remote log-on, client-server, email, file transfer, and web access can be secured. So please look here so that you don't forget it. You don't forget this point. It will secure at the IP level. You know when I say at the IP level, look here. Where is it? These are the layers, huh? It will secure at the IP level. اللي هو network layer, صح? So everything above is encrypted. So all my applications are encrypted. This is what I want. Correct? Go back here. IPsec operates in network devices such as a router or firewall. The IPsec networking device will typically encrypt and compress all traffic going to the WAN and decrypt and decompress coming from the WAN at the receiver side. Does the user feel any difference?
No.
It's transparent. So once you log in, خلاص, you don't feel it. It's like you are sitting in your office. Have you used VPN to connect? I think during COVID we used it, right? Sometime to access our workstations here. Anybody used it? I think some of you. Okay. Secure transmission also possible with individual users who dial into the WAN using IPsec protocols. Allahu Akbar, Allahu Akbar. So here we have non-secure IP traffic is conducted on each LAN. For traffic offsite, IPsec protocols are used. Okay. This is my LAN inside the company. You see here. When I want to send over the WAN, I should use the IPsec. You see where the IPsec is sitting? Okay. Yani the employees are sitting here in the office. When I want to send to Dr. Muhammad, do I need to use VPN just to send email or file to him?
No.
But if we are sending through the WAN, then we might need to use the VPN. Okay. Benefits of IPsec. Provide stronger security to routers and firewalls. Very important, please read them. It is resistance to bypass within a firewall. It is below transport layer, so it is transparent to applications. It is also transparent to end users and can provide security for individual users if needed. IPsec functions. It provides three main facilities. By the way, we are going to do a lab on IPsec. I think lab number 10 maybe. If an authentication only function referred to as authentication header AH, ESP or encapsulating security payload. This is a combination of authentication and encryption, ESP, and a key exchange function. Key exchange you learned in cryptography, right? Did you do any key change? Did you use application for that? Any key? For VPN, both authentication and encryption are generally desired. You should have both. Okay, now we go to the summary here. Please read the summary and let me know if you have any question.